We're going to do the factory workers that are on the assembly line again. Are we going to what? Probably. I'm not sure, but I think we might. So those are, I've got a little bit better picture of them. This right here, the dot plot, I can't really tell anything from that, so we really don't use dot plots very often. The box and whisker plot and the normal probability plot are really good. This is supposed to be linear, and it is, right? Relatively, straight line. This one is supposed to be symmetric. Can y'all see that that's right there?
Yeah.
It's a little bit skewed right, but there are no outliers. And outliers are a gigantic problem. Outliers mean it's going to way skew your data. And over here, if you see little dots out here somewhere, or over here, those are the outliers, but we don't see any, so this one's okay. It's not great, but it's all right. All right, checking your conditions. Once again, I know y'all did it 100 times. I hope that the more we do it, the more you understand it. These were the claims. The Duracell Corporation claimed this. They were actually hoping a group of batteries will last longer than 30. There was a simple random sample of batteries, and it actually said SRS in the problem. We took a sample of 15 batteries. You are the quality control inspector, and you somehow did a simple random sample of 15 batteries. Does 15 sound like enough to y'all?
No.
Maybe. 30 is the magic number. It will be. It will always be normal. Because otherwise you can't finish the problem. And no college board test is going to make you have one you can finish.
Unless they're trying to trick you.
True. I've not seen one yet. All right. So in the last about 4 days, all of our normal, checking to see if it's normal, has been n times p greater than or equal to 10, right? This one is the 30. There is no proportion or p in this problem, is there?
No.
So we can't use n times p.
Oh no.
We use n greater than 30, which is not. But you notice they already gave us some box plots and stuff? All right, look at the graphs on page 566, which were these. These are the graphs. Now, if they don't give them to you, you actually have to input it into your calculator and find them, which we will do. But for right now, let's just be happy about the fact that they did them for us, right? I don't look at this one very often, although you can. The only problem is, if you wanted to use this, you would have to actually draw that on your paper. And that's going to take a little bit, right? This is a whole lot easier to draw. So just go with the box plot every time. All right, there's slight right skewness on the box plot, but no outliers. So this is approximately wrong. You have to write all of that, though. Or draw the box plot itself. You could do that, too. And put some numbers in there with it. But you got to write something and then say, this is approximately wrong. This section can get boring in the fact that we've done it numerous times. But we also could be on the flip side of that and be like, oh, yay, we know what we're doing. Right? Okay, so here is my thing. The next question asks you something about a test statistic, or it's going to, isn't it? The test statistic comes straight from your calculator, from your formula sheet, and there's your formula right there. It only is in words, though. You've got to know what the letters, or the numbers and the letters and all that stuff to put in. All right, yesterday we did statistic minus parameter, and we did p hat minus p. There is no p in this problem, right? So your statistic comes from your sample, S, statistic sample. Look on there and see if they gave me a sample. It was 15 batteries, but what's the sample mean? then is the mu. Parameter means the whole population of batteries. And then standard deviation, there's a formula for that. X bar and mu. Here's your standard deviation. I know it says 9.8, but you still have a formula. You still have to look at your formula sheet. Let's go ahead and fill in what we know. We know all three of these things. All of that was told to you in the problem. Did I put the SX on there? Y'all might need to add that one. I think I left one off. All right, here is your formula sheet. Right there. There we go. There's your formula sheet. It tells you the letters or the words at the top, not the letters. That's going to be an X bar. That's your sample statistic. That's your mu for the whole parameter of the whole population. Your standard deviation, they're going to give you the sample standard deviation, but you still have to put it into one of these formulas to get the standard deviation. Which one? The first one. The top one. So we're going to put 9.8 divided by the square root of n to get that. Okay? All right. Other than that, it's the same problem you've been doing. Here we go. T. Why am I doing a T instead of a Z?
It's a mean.
It's a means problem, isn't it? It's not a proportion problem. So it's T equals, that's going to be your X bar, that's going to be your mu. 33.9 minus 30. Standard deviation goes on the bottom. There's a formula. The formula is standard deviation divided by the square root of 15. We leave here at 11:05, so let me just go ahead and give you all those numbers.
Why would it be 30?
30 is the whole population mean of batteries. All batteries in the factory. 4, 5, 7. All right, so on your bell curve, draw your bell curve. What you just found was a T score, just like a Z score, same thing. In the middle, yesterday in the middle, we put our whole population proportion. So this time in the middle, we're going to put our whole population mean. What number is that? The whole population mean. Is it 33 or 30?
It's 30.
30. 30 goes in the middle. Grace, I think that's what you did on homework last night. You put it together.
Yeah.
The whole population mean goes in the middle. And then we're going to go up by, here's your standard deviation, 2.53 each time. Why am I shading to the right? It's a greater than problem. Notice it's really not a whole lot different today, right? It goes up by 2.53 each time. Since this is a right-handed problem, right-tailed problem, I don't really care about here. I'm not even going to worry about that here. I'm only going to worry about this. There are two numbers pretty much at the beginning of this problem. There's a 30 and a 33.9, right? The middle is your whole population. The line you draw is at the X bar. That's the 33.9. That's when you draw your line. And that is going to be a Z score, but I think, or T score, I'm sorry, we've already found it. It was 1.54, wasn't it? Mm-hmm. Okay, go to your calculator. Let's see if we can do this.
So for the legal, it's just not even in the statistic, not the zero.
Yes, correct. What is my degrees of freedom? Because I'm going to need it in a few minutes. Good. 14. You're going to need it when you go to your calculator. So let's go to your calculator. Distribution. Okay, let's figure out which one.
Average T.
No. No, it's not 4. It's okay.
And that's normal.
Y'all not done this one before.
No. What do we do?
It's 6. Yes, why?
How? Well, that's
Because
crazy.
we don't have the area.
You're right.
That's crazy.
All right, this is important. Everybody listen. This one, we previously have done normal CDF, haven't we? Okay. This inverse norm is when you know your area. This inverse T is when you know your area. I don't know my area. PDF we never use. See how we didn't use the top PDF? It's number 6. And actually on Inspires, it's not number 6, is it?
It's like number 5.
Okay. So you're looking for TCDF. TCDF. My lower is whatever my T-score was. 1.54. So my lower is 1.54. My upper is 1,000. My degrees of freedom is 14. Did you get 0729? Awesome. All right, that is your area. Do I need to double it?
No.
Good. There's not 2 of them. And that's kind of why they want you to draw a bell curve, to jog your memory and be like, oh yeah, there's 2 of them, I need to double that. That's your PDF. Okay, let's conclude and we will be done with this problem. Or not. Never mind. We didn't ask you to, did it?
Looks like we're done.
Is that really?
Oh, yeah, we're done.
They didn't ask to do anything.
Sure did. We're done.
Yay!
Hey, can you conclude in your mind though?
Yeah.
Is this p-value low?
No.
You failed to reject the hoe on this one.
Maddie, quickly.